Venkatchalam, Venkatachalam, Vivek, Vivek, Vivek,
Sir, good morning, sir. Sir,
Prakash,
sir, good morning, sir.
Prakash,
Sir, sir, கேக்குதாங்க sir?
Prakash, audible. Am I audible?
Yes, sir.
Okay, Prakash. Okay.
Okay, thank you, sir.
Thank you.
Hello. Hello. Hello.
Hello. Good morning.
Sir. Unmute. சரியா? அடுத்து இது இல்லையா? சரி சரி.
Without mathematics, there is nothing you can do. Everything around you is mathematics. Everything around you is numbers, says Shankadevi, a human computer.
Mathematics, a divine morning to all dignitaries, guests, and delegates with great joy and immense exultation.
It gives us great pleasure to extend to you all a very pleasant welcome on behalf of PG and Research Department of Mathematics, Kunganadu Arts and Science College, who has clubbed all of us here for the 4th International Conference on Current Scenario in Pure and Applied Mathematics 2021.
In this international conference, dignitaries from different parts of the country actively participate to enhance the quality, quantity, academic function of the student from who are engaged.
It is a mark of our undying tradition to invoke the Almighty at the beginning of an event.
Prayer works wonders. Prayer should spring from the heart.
Thinking of a supreme power beyond all human inadequacies as a kind of auto-suggestions.
To enlighten us and to brighten our morning, let us begin this inaugural ceremony by seeking the blessing of Lord Almighty with a prayer song. For that, we could like to call upon our students, Miss Deepika and Miss Shamali, to grace this occasion with a prayer song.
Gamadani damada mama, gamadani sa ni sada, dani samari sa sani re sani sada, ni damada mama, gamada magari, ri gamagari gari sa. அறிவிலே தெளிவு நெஞ்சிலே உதி அகலே அன்பினோரும் பொறிகள் மீது தனியரசாலை பொழுதெல்லாம் நினது பேரருளின் நெறியிலே நாட்டம் கருயோகத்தில் நிலைத்திடல் என்றிவை அருளாய் குறி குணம் இளதாய் அணைத்தாய் குலவிட தனி பரம்பொருளே பரம்பொருளே பரம்பொருளே.
Thank you, Heavenly Aerials, for letting the goodness spark to a spiritual chain reaction with your angelic voice. A leader is one who knows the way, goes the way, shows the way. Now we could like to the most respected and head of the department, Dr. V. Koglavani ma'am, to welcome the dignitaries and participants.
A very good morning to one and all present here. I deem it a great honor and privilege to welcome you all to the 4th International Conference on Current Scenario in Pure and Applied Mathematics. I record my deep sense of gratitude to our most esteemed President, Dr. M. Aruchami sir, and Dr. C.A. Vasuki madam, Secretary and Director of our college, for their unstinted support and inspiration. I'm happy to welcome our most respected principal, Dr. M. Lakshmanasamy sir, who never fails to offer words of encouragement to all our activities. We are delighted to have amongst us Dr. V. Sinusamy sir, Chief Executive Officer, Dr. S. Paulsamy sir, Dean Research and Development, and Dr. S.R. Madan Sankar sir, Dean Academic. Great souls that always renders their support and presence in all our endeavors. I welcome you all, sir. I'm extremely happy to welcome the resource person of today's inaugural function, Dr. Ismail Nancy Gangul, Professor, Ultag University, Turkey, for accepting our invitation and gracing this occasion. Your presence today in this function has immensely enhanced its importance, sir. We are eagerly waiting for your insightful address. I welcome you, sir. I also welcome all the distinguished resource persons for forthcoming technical sessions. Professor Taufik, University of Jemper, Indonesia. Professor Ayman from American University of Salta. Professor Falcon from Spain. Professor Nissa from Saudi Arabia, Professor Oliver from Germany, Professor Syed Jafari and Professor Alexander from Denmark, and other invitees who graced this occasion with their presence. A warm welcome to you all. I take this opportunity to welcome our most respected former principal, head of the department of controller ICCSPAM madam, librarian Dr. R. Sendil Kumar sir, Dr. Sarga sir, Associate Dean for Research, Dr. N. Nagaraj sir, Dean School of Computer Science, and Dr. Jayakumar sir, Dean School of Commerce, to this conference. A warm welcome to you all. The successful culmination of this program owes much to the support of all my dear colleagues of the department and my dear students for their overwhelming participation and their cooperation for organizing this conference in a fruitful manner. My warmest welcome to you all. Hope This conference attains its fulfillment in sharing new ideas and concepts in the field of pure and applied mathematics. Once again, I welcome you all to this conference. Thank you all.
Thank you, ma'am. Great people not only seize the way, they pave the way for victory. I request Dr. V. Chinnuswamy Sir, Chief Executive Officer, Kongnada Arts and Science College, to deliver the presidential address. Sir, please.
Yes, thank you. Good morning to all, most respected and most distinct eminent professors, Dr. Ismail Nazi Kangul, Turkey, Professor Ayman Retef Badabi, United Arab Emirates, Professor Zayed Safari, Denmark, Professor Dafiq, Indonesia, Professor Raul M. Falcon, Spain, Professor Oliver Rijodi, Germany, Professor Alexander Bikasini, Denmark, Professor K.S. Nizar, Saudi Arabia, and our professors, Professor Dr. Balsami, Dean R&D, Dr. Madan Sangar, Dean Academics, Dr. Nagarajan, Administrative Dean, Dr. Jaykumar, Dean, School of Commerce and Management, Dr. Sukumar Sarvas, Associate Dean, organizers, learned professors, participants from our college and other colleges, good morning to all of you. And once again, we welcome on behalf of our college and the Department of Mathematics to this international conference on current scenario on pure and applied mathematics. Our Department of Mathematics, Kongunad Arts and Science College, is one of the most promising departments in our institution. The faculty members are fully, actively engaged in not only teaching and research. They all are involved in fully research. So far, they have produced 39 PhDs, 162 MPhil degrees. They have been awarded. The staff members have published more than 500 research papers in the national and international journals with very good impact factors, that is journals of Scopus journals and SCI journals. During this pandemic year 2020, this year alone, they have published 41 papers in Scopus and 21 papers in SCI journals. They have consecutively organized the international conference for the past 4 years. For conference on the on current CEO and applied mathematics, we have received 125 papers from various spots: Turkey, Thailand, Malaysia, Indonesia, and different states of India. So congratulations to all. Thank you, the organizers, for organizing this type of conferences that are particularly useful to researchers and students. So I am very happy to share a few thoughts on recent trends in mathematics. That is, mathematics. What is the recent trends in mathematics? Is in day-to-day life and is being used even when people don't realize they are using mathematical reasoning. Almost all areas of human activity make more and more use of mathematics. They use all branches of mathematics, not just traditional applied mathematics. Mathematical activity like research, applications, education, exposition has changed a lot in the last some years. Some of these changes, like the use of computers, are very successful and they are being applied in mathematical education very early. Many new forms of mathematical activity like algorithms and programming, modeling, conjecturing, expository writing, and lecturing are acquisition significance. The 20th century made a rethink on the boundaries of mathematics. It was marked out for a new approach of mathematics. David Hilbert in 1862 to 1940, his vision was to analyze axioms of each subject in their full generality. This vision became concrete in the year 1930 through the development of axiomatic approach to algebra. Parallel trends took place in functional analysis with Banach spaces. This extends to other subfields of mathematics like partial differential equations, harmonic analysis, and algebraic topology. The 20th century approach to mathematics resulted in a more developed mathematical language, new powerful mathematical tools, and inspired new application areas that have resulted in a remarkable discoveries in other applied sciences. Towards the end of the 20th century, mathematicians were making a rethink on the need to bridge division lines within mathematics, to open up more for other disciplines, and to support the line of interdisciplinary research. The current cry is that this interaction will be further stabilized in the 1st century. In the drive to duality, 20th century mathematics become more diverse, more structured. So this about the 20th centuries. Now coming about the new trends, the universal presence of the computer. This makes a big role in mathematics. The use of computers and its role in actually the changing the face of mathematics. The computer plays an entirely constructive role in our lives and in the evolution of mathematics. The computer is changing mathematics by bringing certain topics into greater prominence. It is even causing mathematicians to create new areas of mathematics. For example, the area of computational complexity, the theory of automata, mathematical cryptology, etc. At the same time, it is relieving us of certain tedious aspects of traditional mathematical activity, which it executes faster and more accurately than we can. It makes it possible rapidly and painlessly to carry out numerical work, so that we may accompany our analysis of a given problem with the actual calculation of numerical examples. On the other hand, the computer renders obsolete certain mathematical techniques which have been prominent in the curriculum till now. Many educational technology companies are hiring those with a masters in mathematics, not just teaching mathematics, but subjects like data science concepts, computer science algorithms, applied mathematics. So if you look at the data science in research and MNC company in technology and finance, they are all PhDs in mathematics, data science. Then robotics, machine learning, etc. So the hiring in mathematics have increased by leaps and bounds. Applied mathematics, statistics, and probability have huge takers. PhD mathematics are a big demand in data science, artificial intelligence, machine learning. So massively surging in the economical world. See, you have very good experts. If you are expert in mathematics and statistics, the foreign companies like giving lot, so many lakhs of dollars in dollars giving off. a candidate with a good people. You should utilize this and the flying colors in our life, because the mathematics and statisticians, and also the various fields for mathematics used in various fields. Example where mathematics is emerging vital. Mathematics, one mathematics material science, and another is security. Mathematics for information and communication, mathematics sensors, communication, as well as network security protection. Another is demonstration reliability, where mathematics is long. Another, the requirements for automated decision making. So that's also required mathematics. Well, for example, the stochastic analysis, mathematics of sensing, pattern analysis, and spectral analysis. Then another way is future systems, that is lighter weights, smaller satellites, ICCSPAM receptor, before the wireless communication systems, efficient AC, powers, modeling and simulations, robotics, and automation. So these are some of the areas. No more, still are there, but these are the few important areas where the mathematical stage is highly useful. During the last 50 years, development in mathematics in computing and communication technologies have made it possible for most of the breathtaking discoveries in basic sciences, for the remarkable innovations and inventions in engineering sciences and technology, and for the great achievements and breakthroughs in economics and life sciences. These have led to the emergency of many new areas of mathematics and enabled areas that were inactive to explode. The examples are from of material science, study of composites, digital technology, and health care. So these are various some of the areas where these mathematical concepts because limited times the speakers are there. So I have this few examples I will give. One or 2 points. Today, it is a vast growing knowledge about physical sciences, engineering. For example, mathematical models are available in the synthesis and manufacture of polymers coming into material science. Some of these models are based on statistics, statistical mechanics. Others are based on a diffusion equation in finite or infinite dimensional spaces. Simpler but more phenomenological models of polymers are based on continuous mechanics with ordered terms to account for memory. Stability and singularity of solutions are important issues for material science. The another is study of composites, where there are a lot of mathematical ideas are used. What is that composite? Motor companies, they are working with the composites of aluminum and silicon carbon grinds, which provide lightweight alternative to steel. So the alternative to steel. Fluid with magnetic particles or electrically charged particles will enhance the effects of brake fluid and shock absorbers in the car. Over the last decade, mathematicians has developed a new tool in functional analysis, partial differential equation, numerical analysis, where by which they have been able to estimate or compute the effective properties of the composites. But the list of new composites is ever new materials are constantly being developed. These continue to need mathematical input. Then another important field in using mathematics is mathematical in digital technology. This is a very, very nowadays useful. This studies of multimedia encompasses a wide range of research areas, which include computer vision, image processing, speech recognition, and language understanding, computer-aided design, and new modes of networking. The mathematical tools in multimedia may include stochastic processes, Markov fields, statistical patterns, decision theory, PD, numerical analysis, graph theory, graphic algorithms, and image analysis, and wavelets of many others. Computer-aided design is becoming a powerful tool in many industries. This technology is a potential for efficient. The future of the World Web will depend on the development of many mathematical ideas and algorithms. And mathematicians will have to develop even more secure cryptographic schemes. And thus, new developments from number theory, discrete mathematics, algebraic geometry, and dynamical systems, plus other fields. So these are some of the ideas about that in digital technology. There are a lot of things are there, but limited time, so I am going just to short all these things. And also the mathematics is used in the medical field also. Nowadays, a lot of mathematics is used. A doctor, a nurse, X-ray technician, pharmacist, and all others in the medical field should also keep the knowledge of mathematics. So they have to use the mathematics in different walks of life, and that is with that treatment. The functions of the nurse also very important. That is reading the pulse, counting the number of beats for a few seconds, prepare patient chart for many factors. So understanding of the basic mathematics is essential for a nurse. Maths is certainly a large part of a pharmacy. Pills must be counted. Formulas must be calculated. All maths functions that require proper administration by a pharmacist. So with this, a few words I will conclude this now. As a conclusion, every branch of mathematics has a potential for applicability in other fields of mathematics and other disciplines. All these have posed a big challenge for the mathematics curriculum at all levels of the education systems, teacher preparation and pedagogy. The 21st century mathematics is to further strengthen the efforts to bridge the division lines within mathematics, to open up more for other disciplines, and to foster the line of interdisciplinary research. So mathematical students, please, you have to develop your skills in various digital technologies, especially in artificial intelligence, cloud computing, machine learning, robotics. So these are all the very, very important processes, cyber security, cryptography. These are all some of the areas you have to acquire skills. So you have to get a jobs, very good jobs in multinational companies. So with these few words, I thank you, the organizers, for organizing such a wonderful conference, and we wish this conference a grand success. Thank you, one and all.
Thank you, sir, for your valuable words. The future belongs to
Thank you,
those
madam.
who
Thank you.
believe in the beauty of their dreams. Now I invite Dr. Paul Sami, sir, Dean, R&D, Konganadu Arts and Science College, to inaugural address. Sir,
Thank you, madam. Most esteemed Secretary, madam of our college, respected principal, most respected CEO, sir, beloved academic dean, and associate dean R&D of our college, head of mathematics department, the organizing secretary, and other faculty members of the mathematics department of our Konganadu Arts and Science College, and the most distinguished the resource persons, Dr. Ismail Nasi Kangul, Uludağ University, Turkey, who is going to deliver a keynote address in this conference, Dr. Dafiq, University of Jember, Indonesia, Professor Badawi, American University of Sharjah, Professor Falcon, University of Sevilla, Spain, and Professor Nisar, Prince Satam bin Abdul Aziz University, Saudi Arabia, Professor Ager of Germany, and Professor Syed Jafari and Alexander Pisasny of Denmark, and learned professors from various departments. And my dear participants, good morning to everybody. It is a great opportunity for me to inaugurate the 4th International Seminar Conference on the current scenario in pure and applied mathematics. So our college faculty members of mathematics are so young and energetic, and they have done a lot of work, not only in the area of research and also in the social activities. So as stated by our CEO sir, during pandemic period, that is the only department published more number of articles in reputed journals. So very high quality journals, they publish their articles. Other than that, they involved in other activities, social activities all during the pandemic period. I congratulate the team, entire team, for this hard work in the area of mathematics. So today, the pure and applied mathematics, the development of pure and applied mathematics, that is the basic concept of the conference. The research and the outcome of the research in pure mathematics is the basic for the applied mathematics. So whatever the things we are doing in our college in the mathematics, they are basic, and most probably they are the founding stone for the applied mathematics. So many areas in the history we have seen, so many areas, biology, physical science, chemical science, the application of mathematics is most important. Even in our day-to-day life, maths is very essential. Other than that, for our social activities, our research in the environmental areas, forestry, biology, everywhere, the mathematics is available. Only by mathematics only we can get very fruitful results. Based on that, we can frame to any type of things. So particularly in the chemistry, graph theory and topology are much used. Similarly in physics, the calculus and the linear algebra, these are all the the method of Indian mathematics process is one of the most important area where the legacy of Ramanujan is much used. Another one is the black hole of physics. In the there is a black hole. The description of the black hole is fully based on the Ramanujan legacy recent years. In the signal processing, the digital processing of signals include the most obvious our speech and music, and the research-oriented DNA sequence, protein sequence, everything they are coming under signal processing. So in the signal processing, there are certain patterns which are repeated, come again and again, that are the periodic pattern. In the pattern, the isolation of the pattern that can be done by certain things like the Fourier analysis. Fourier analysis is only because of the trigonometric function, the Fourier analysis has been made. So to isolate and identify the pattern available in the signals, that can be done through Fourier analysis mainly. But in recent years, just 2 years, Professor Vaidyanathan of California Institute of Technology, he is a mathematician. He analyzed the Ramanujan sums. Based on the Ramanujan sums, it goes like this: C1 plus C2, C3, and so on. So Ramanujan sums, in that he derived certain Ramanujan subspaces there. These subspaces are very similar to the used to Fourier analysis. It is greater than Fourier, and very easily and very quickly we can analyze that based on the Ramanujan subspace derived by Professor Vaidyanathan. it is most applicable recent years. Most of the physicians and also the mathematicians using this way to analyze the periodic pattern. And another important area, that is black hole of physics. What is black hole? Actually, the very oldest stars at the end of the life cycle decomposes. That means they become very bright and ejecting lot of mass, due to which a hole or black spot appear, that is called as the black hole. That is the largest explosion in the space. That is called as the supernova. Supernova is the largest explosion in the space by the oldest stars. So this black hole formed is the one of the greatest area of the gravity in the space. Even light cannot escape. The light also be absorbed by the gravity of the black hole. That's why it looks black. So the description of the black that can be made in different ways. In recent years, the Ramanujan partitioning of the number, that is one of the important contribution to mathematics by our genius Ramanujan, partitioning the number. Simply the 3 can be written like 1 plus 1 plus 1 or 2 plus 1 like this. So if the number to be partitioned is so large, the possibility of the partition will also be large. So this is the concept. Based on this concept, he introduced the Mach theory, Mach theta functions. In his famous letter to his mentor Hardy, he introduced the Mach theta functions. From there, it is very similar to the modular forms. Modular forms is a factor which is most useful to describe the black hole. So the Mach theta functions are very close to modular forms, based on which the characters of the black hole is described nowadays by physicists. So it is also another application of the Ramanujan. See, so many things available in the Ramanujan works. People like all are contributed to mathematics in the way of applied mathematics. And another important area, the Nightingale, Florence Nightingale. Basically, she is the lamp with lady, popularly known as lamp with lady, and social reformer, a statistician, and also he is a founder of modern nursing. So this lady in some 200 years back, 1820 to 1856, that was the period of this Nightingale. So he basically a mathematician, school teacher. So during the time of Crimean War happened between 1853 and 1856. Actually, why the Crimean War happened? So Turkey, a country connecting both the Asia and Europe, the most geographically and geologically, it is most important country to connect these two continents. And Russia need a ocean connection through Mediterranean Sea and wants to occupy the Crimean island, Crimean peninsula in the Black Sea. But Turkey fought against the Russia. The France and the UK also joined with the Turkey and fought against Russia at the time in 1953 to 1956. During the time, lot of casualties happened in the war field. So the War Secretary Frederick of UK sent his friend the Nightingale to the war field. Nightingale along with the 35 members came there, and she observed lot of deaths happened in the camps alone, not in the war field. The wounded soldiers, they are very less, but casualties happened mostly in the camps. So she observed, and then actually in the pandemic period, we followed a lot of things like the sanitizing our hands and the social distancing, wearing masks. These are the techniques introduced by Nightingale at the time. So she observed that in campus, the wounded soldiers, they are crowded, so crowded. There is no sanitary facilities there. There is no pure drinking water there. And so, based on the observation, he wrote a letter to the English government, UK government, and she emphasized the need of the social distancing, pure air, pure water, everything for the soldiers. And then, by following all those things, she reduced the death rate from 40% to 2.2% within a year by using all these things. For that, she prepared a polar chart. polar chart is purely based on the mathematical formula in which three colors are there. The blue color, it is indicating the infectious diseases, and the red color indicating the death occurred in the war field due to wounds and other things, and the black color that indicates the death due to other infectious diseases, other reasons, some other reasons the death caused in the war field. So this polar chart, it is based on the mathematical model. He explained all those things to the higher authorities of UK government and bought all those things for the camp. Finally, he reduced the death rate from 40% to 2.2%. After return, actually after completing the war in 1956, he returned to UK, and by using many mathematical models, he all over the world, he collected the information about the hospital patients, the persons infected by infectious diseases, etc., and prepared a model. This model still now we are following these models in the pandemic period also. So one of the greatest mathematician, the knowledge of the mathematics is highly applied in the area of humanities and areas. And recently, in January this year, January 20th, one article has been published in the this climatic and atmospheric science, a most popular journal. In that journal, one article has been published by our group of IIT members, Gandhinagar, regarding the prediction of flash droughts in India. Flash drought, a continuous hot summer without rainfall, that is simply called as the drought. The flash drought, it will occur within a week. Within a short period of 1 week, the flash drought will occur due to the sudden decrease in soil moisture. Number of other meteorological factors are also responsible. So many factors are there: soil temperature, the air temperature, and other things. So they obtained a score that is called as the severity score. This is also based on the mathematical formula severity score they obtained. Based on the severity score, they observed the flash droughts since 1951 to 2016. They arranged the order in the order 1979. We have experienced a very severe flash drought, during which nearly 40% of the Indian subcontinent was disturbed. After then, in 2009, another severe drought, and 1951, that is less severe drought, and 1986, 2005. These are all the five major flash droughts occurred in the last some 75 years. They have been observed. This is predicted by using the severity score, a model, a value, quantitative value obtained by the our Indian scientists. And then the severity score, actually, it is the simulation of the soil moisture and other meteorological data. The simulation model is used for obtaining the severity score. To predict the flash droughts, now the Earth system model that has been used is used in which they simulate rainfall, temperature, El Nino, Indian Ocean dipole, equal Indian Ocean oscillation, Madden-Julian oscillation. These are all some meteorological events happened in Indian Ocean and Pacific Ocean, due to which the monsoon rain occurred in countries like India. We can even predict the monsoon very accurately by adopting these factors. So simulation of all these factors, that is called as the community Earth system model, now they are using. Based on that, the people of Gandhinagar IIT, they have predicted within the completion of this century, many such flash droughts will occur, particularly for the forthcoming 3 decades. We will experience most number of the flash droughts. The frequency and the density of the flash droughts will be more in the coming years. So based on the prediction is purely by scoring certain index values. And then this will affect our agriculture production, irrigation demands, and the groundwater abstraction. These are all the things that will be highly affected by the flash droughts. Even now, our you know that HIV is causing this, you know, that it is an RNA virus causing the AIDS. So this is mathematical model is very much useful to control the HIV virus. Actually, this is most successful virus in human body because of the incredible mutation. Mutation, that is the process of replication in a very rapid rate occurring in this virus, and due to which it reproduces very rapidly. So the mathematical model submitted is having certain threshold number for mutation. If you push the number or push the virus beyond the limit of the threshold number, the genetic information area of the virus will get collapsed. Finally, the virus become non-infectious. The infectious virus become non-infectious when you push the virus beyond the threshold number for mutation. So that is the new invention made based on the mathematical model nowadays. Any areas in space science, astronomy, astrology, in all these areas, the mathematics are most important. So our department people, the mathematics department people, so young and dynamic, very interested in research areas, and they are conducting this type of conference in the fourth consecutive year. The recent scenario in the pure and applied mathematics. So they are organized well this function. Many internal professors, they are going to deliver their lectures. The contribution in the mathematics area is so high. So definitely it will be most useful for all the participants in this conference. I congratulate the team for organizing this type of seminar every year. So it is the interest of students and the interest of staff members and the interest of other research workers. This type of conference will be more. Finally, I congratulate the team and the conference for the grand success. Once again, I thank the organizers for having given me the opportunity to inaugurate the function. Thank you very much.
Thank you, sir, for your valuable words. The optimist sees the opportunity in every difficulty. Now I request Dr. S.R. Madan Shankar, sir, Dean Academics, Konganadu Arts and Science College, to deliver the felicitation. Sir, please.
Good morning to all of you. Most esteemed Secretary and Director of the institution, Dr. C.A. Vasaki, Principal, Dr. Lakshman Swami, Dean R&D, Dr. Palasamy, Associate Dean, Dr. Sivaprakash, the most lovable Chief Executive Officer, the Head of the Department of Mathematics, and the most vibrant and dynamic mathematicians of this great institution. A warm good morning to all of you. I'm happy to be a part of this conference, which is organized in the fourth consecutive year on recent advances in pure and applied mathematics. We have heard a marvelous speech by our CEO and our Dean R&D. They have left no stone unturned. They have given you an overview of how mathematics is applied at different areas. And I would say that they have set the stage for the 2 days proceeding as well. I will take you back to the Vedic period. I will take you back to about several years ago, how the Vedic Aryans, or how the great Bharata had a stand in mathematics. Now, as you all know, our country, Bharata, has a quite impressive heritage of mathematics, which dates back to the Vedic period, very, very early Vedic period. This particular subject, which is very extraordinary and which is application oriented, actually grew from the time of Vedas. I would say they grew in conjunction with the Vedic hymns, the Vedic mantras, Vedic sutras, and several other religious things, which we have branded it as religious in the current scenario. So it has been growing since time immemorial. Most of the mathematicians will know about the Pythagoras theorem or the Pythagoras theorem, which is used in plane geometry. The most interesting fact is that this particular concept of Pythagoras theorem dates back even before the time of Pythagoras to several 100, 200 or 300, more than such years before Christ and before the Pythagoras. invented this particular concept. And in several Vedic scriptures and in several Vedic mantras and hymns, concepts of Pythagorean geometry is being very clearly debated and very clearly understood. So here, lest is that we have to really reiterate or really understand how the Vedic Aryans or how the people understood geometry, understood different aspects of count, different aspects of algebra, different aspects of geometry. What has happened over of time is that the debate on the dating of ancient Indian discoveries, particularly with reference to mathematics, science, etc., they have undergone severe damages at the hands of a zealous historians who have distorted the history and who have not given the correct picture. So perhaps I would say that today's mathematicians, particularly these young generation students, should revisit and understand such matters of significance and such matters of importance, lest we stray from the mathematics in hand. And I would reiterate that the whole body of knowledge that stemmed out from Vedic rituals primarily through their sacrifice. So most of the formulas, most of the sutras actually stemmed out of these fire sacrifices, etc. The corpus body of the entire mathematical knowledge was actually called as Sulabh Sutra. You know, this Sulabh Sutra was actually propitiated by Baudhyayana in 500 BC itself. And this is simple Pythagorean geometry was seen in Sulabh Sutra. To explain the meaning of what you mean by Sulabh and Sutra, Sulabh is actually meaning that it is a piece of cord or a piece of string that is used for measurement. And Sutra is a formula. And this Sulabh Sutra was initially used for construction of various sites, particularly construction sites for performing yajna or for performing homa or for performing some kind of religious fire sacrifice. So the exact depictions of the Sulabh Sutra is actually seen at several levels of Vedic scriptures as well. Not only that, we all know about Vyakarana means grammar. Everybody thinks that grammar is something to do with language. But the great proponent of Vyakarana was Panini. Panini, 500 BC or 520 BC, was a person to talk about operations. And similarly, you must have heard about Pingala. Pingala is another great philosopher of that time. And this Pingala, you all are very well aware of Pascal's triangle. So Pingala was the first person to depict Pascal's triangle, you know, for what? For architecture of Mount Meru. You know, this was called as Meru Prastara. It was called Meru Prastara, and this Meru Prastara is actually Pascal's triangle. Not only that, several Samhitas and several Brahmanas and several mantras which constitute the Anna Homa. That is, I told you everything stemmed out from fire sacrifice. So several such things that was used for Anna Homa, the mantra that was recited were in the powers of 10. I would give you one or two examples of how it was in powers of 10. When you see here, it starts from to about a trillion. Now Sata was called as 10, that is 10, number 10. Then comes Sahasra. Sahasra is 1000, which is 10 power 2. Then you have Ayuta. Ayuta is 10 power 4. Prata is 10 power 6. And Buddha is 10 power 7. Nyarbudha is 10 power 8. Samadha is 10 power 9. Adhya is 10 power 10. And Anta, which means end, which is 10 power 11. And Pararada, which is 10 power 12, which is 1 trillion. So the mantras that was given in fire oblation or Anna Homa had all these counts and all these numbers which you see in the Vedic period. So this particular thing which is under debate is going to be deliberated for the next 2 days. I urge that all the participants and all the speakers will throw great light on pure and applied mathematics in the current scenario. But the only thing that is lacking here is how are we going to blend this modern discovery or modern science or mathematical principles and relate it back to what we have seen in the Vedic period. So if at all few of them or few of us can do this job, I think we'll be able to revisit several other concepts into mathematics and see that we bring back the glory of Bharata back into action, and we would be number one in logical reasoning as well as mathematical reasoning. Having said these few words, I take pride in being a part of this conference and wish that the conference have massive and astounding success. And I hope every participant will have some deliverable and some outcome to take back to his office, take back to institution and start working on it. And I also congratulate the entire team of faculty members, the entire team of students, and the entire team of all the other people who are associated with this program, and wish all success. Thank you so much for the opportunity and nice deliberations in the next 2 days. Thank you.
Thank you, sir, for enlightening noble words. I request Dr. N. Mohanapriya ma'am, Assistant Professor, PG and Research Department of Mathematics, Kongnadu Arts and Science College, to introduce the chief guest.
I have a very pleasant duty of introducing our chief guest, Professor Dr. Ismail Nazi Gangul. Professor Gangul needs no introduction. He is very well known and one of the most distinguished mathematicians of Turkey. Yet the occasion demands, and here it is in brief. He started his first MSc at Uludağ University, Faculty of Arts and Science, in the year 1987. After completing his MSc again, he was sent to UK for academic research by a HEC grant. He did his second MSc in Warwick University between 1989 and 1990. Later, he moved to South University in 1990 to pursue PhD along with some countries. He completed his PhD in the year 1994 on the topic normal subgroup of Haki groups. He did compulsory military duty for 16 months in the main headquarters of the Turkish First Army between 1994 and 1995. After completing his military duty in 1995, he became an assistant professor at the Faculty of Arts and Science in Uludağ University. In 1999, he became an associate professor and professor in 2005 till date. He attended over 100 meetings and gave many seminars. He had been the Dean of the Faculty of Arts and Science for 6.5 years between 2008 and 2015. He acted as a Rector Advisor and International Relations Coordinator with additional crown during. He has written 49 books and over 200 scientific research articles which were published in well-reputed scientific journals. He collaborated his research work from Turkey, India, France, UK, Canada, USA, Japan, etc. Under his guidance, 21 students have completed their PhD. For his pioneering work, he received many awards like highest number of annual publication prize in 2011 and 2013, the special prize for Bolgano Coordinator Committee member in 2011, highest number of annual projects in 2012, Scientist of the Year 2012, the Annual Successful Academician Group Prize in 2012, the Best Performance Award in 2016 in Uludağ University. He has been acted as an editorial board member in 21 international scientific journals. He is a member of 6 national and international mathematical society. But more than these accolades, he is an extremely nice human being. I am very much grateful and honored that he has consented to release our 4th international conference virtual abstract book along with our dignitaries and participants. So please.
Thank you. Good morning to all. Shubhodaya. I'm happy to be. Thank you. I'm happy to be with all of you, the team of ICCSPAM in Congonado Arts and Science College, and I'm glad to release the abstract book of the fourth conference. I hope it will be a good start to the conference, and I hope many more to come. So I release. Yes. Okay. Shall I continue with my talk?
Professor, just move this file.
Okay, yeah. Forwards by Vasuki, Madam, by the Principal Lakesh Manaswamy, by me, by location, my dear friend, by Dr. Kokilvani, and the program schedule is next with technical sessions and the validator function at the end, and the contents, the most important part. So, thank you.
Thank you, Professor. You can continue your talk.
Okay, thank you.
Thank you, sir. Knowledge is like a garden. If it is not cultivated, it cannot be harvested. Now we request distinguished chief guest, Professor Dr. Ismail Nabil, Professor, Uldag University, Faculty of Arts and Science, Department of Mathematics, Turkey, to deliver the keynote address.
Thank you, Manapriya. Dear organizers and participants of the fourth International Conference on Current Scenario in Pure and Applied Mathematics, Congress, and also to the inaugural function. First of all, I wish to extend my sincere congratulations and thanks to all members of organizing committee of this important academic meeting in Congonado Arts and Science College in Coimbatore, Tamil Nadu, for organizing the fourth of ICC's in a row under the existing conditions, especially all around the world. My friends in PG and Research Department of Mathematics at Congonado Arts and Science College are producing a great job for the last 4 years in organizing this series of conferences. As a part of all 4 conferences, I'm glad to see that each new meeting is rapidly getting bigger and ICCSPAM is taking its place in the area of international conferences. I wish all the success to administration and academicians in continuous organization of this conference series. Particularly to mention, I would like to thank to the President of Congonado Arts and Science College, Dr. M. Aruchami, Secretary Director, Dr. C.A. Vasuki, Chairman Principal, Dr. M. Lakesh Manaswamy, Dean, Dr. S. Paulsamy, Academic Dean, Dr. S.R.M. Shankar, Head of Department, Dr. V. Kokilavani, Coordinator, my dear friend, Dr. M. Venkachalam, and Organizing Secretaries, Dr. L. Vidyarani, Dr. N. Mohanapriya, and Dr. A. Prakash. They do a great job indeed. Fourth International Conference on Current Scenario in Pure and Applied Mathematics is gathering online many researchers from all over the world, and also getting the care of many others Such academic meetings are important places where academicians can share their ideas and thoughts. But these meetings are especially important for young academicians in the spring of their career, as they can meet a senior whose papers they've been reading, learn about new trends in mathematics, research, establish new cooperations and friendships, which may change their careers and the way they look at mathematics. Each time I come back from a congress, I feel like I know nothing and need to work very hard. Following all the talks, I always got motivated with the fascination and wide range of topics that the others are working on. A word, a picture, a formula that I saw in a talk in a conference many times gave me very important research problems. So listen very carefully to each talk, especially my young friends. Unfortunately, in the last few decades, governments are reducing their interest in fundamental sciences, including mathematics, naturally, due to some meaningless reasoning. Most policymakers believe that scientists must earn money directly. This is, of course, something everybody wishes. Money is important for all of us. But nowadays, knowledge is more important. A simple idea like Facebook or Twitter produces more money than millions of farmers earn working all the year long. Someone developing a computer software or an operating system is earning more money than many other countries' budgets. So technology is producing more money than ever. India is one of the best examples in the world. But technology is getting old very rapidly. The answer to the question that how can we keep technology up to date is mathematics, basically mathematics. Many things can be modeled and studied nowadays. A model is easy to produce and study. In many areas of science, things or cases are modeled and such models can be studied by means of mathematical methods. For example, I will give an example from my recent research area, graph theory. In molecular chemistry, molecules can be modeled by graphs. Atoms correspond to the vertices and chemical bonds between the atoms correspond to the edges of model graph. Once you do this, you can calculate some mathematical formulae, very easy formulae, called topological graph indices by mathematicians or molecular descriptors by chemists. And you can comment on physiochemical properties of the molecule just by looking at the results obtained by these formulae. You do not need to go laboratory to spend days and sleepless nights, nor you don't need to spend a lot of money on machines or chemicals. This is just one application. You can do some calculations and you can see the real life. You can comment on real life examples. Of course, there are many other examples in mathematics. Science is a whole body. Without physics, there would be no mechanical engineering. Without chemistry, there would be no textile engineering. Without biology, there would be no veterinary sciences nor agriculture. Without statistics, there would be no social science, and without mathematics, there would be no science. Therefore, to produce money by means of science, as the governments require nowadays, we must subsidize fundamental sciences. and especially mathematics and statistics. It's like a family, I think. Father, and in some cases, mother works and earn money for whole family. The children, and if they are their grandparents, are the consumers. But they are never blamed not to earn any money. The children are investments of the father and mother for the future. I just hope that the policymakers, politicians realize that mathematics is so prestigious like our children. And without it, there is no technology, there is no future. I hope ICCSPAM 2021 will be a fruitful one to be remembered in many years to come, and everyone will have nice memories and new problems out of it. I wish all the participants healthy days full of mathematics together with their families and beloved ones until the next ICCSPAM. Thank you.
Thank you, sir. Gratitude is the fairest blossom which springs from the soul. I request Dr. L. Vidyarani to Assistant Professor, PG and Research Department of Mathematics, Kongnadu Arts and Science College, to deliver the oath of thanks.
Thank you. A very good morning to all the honorable dignitaries, participants, and my dear friends. It's not happiness that brings us gratitude. It's gratitude that brings us happiness. All our dreams come true if we have the courage to pursue them. I am L. Vidyarani, Organizing Secretary of ICCSPAM 2021, proposing vote of thanks on behalf of PG and Research Department of Mathematics. It's my great privilege to thank our Honorable President, Dr. M. Archami Sir, for his blessings. He is a person with high vision and sown the seeds of research in the minds of our senior professors, which results, and we are here with this conference. I express my profound and sincere thanks to a wonderful lady, our most respected secretary and director of a college, Dr. C.A. Vasagi Madam, for providing an excellent opportunity and support to conduct this valuable 4th International Conference in our esteemed institution. I extend my heartfelt thanks to our most respected principal, Dr. M. Lakshmanasamy Sir, for his constant support in all our activities. I render my sincere thanks and gratitude to our respected CEO, Dr. V. Chinnasamy Sir, for his wonderful presidential address. So we were very happy to hear the importance and applications of mathematics that came. Sir, your support and encouragement makes our department to move to greater extent. Thank you very much, sir. I submit my sincere thanks and gratitude to our most respected research dean, Dr. S. Polsamy sir, for his inaugural address in this conference. Sir, though you are a botanist, you have given lots of applications of mathematics. Thank you very much, sir. I extend my gratitude to our Dean Academics, Dr. S.R. Madan Shankar sir, for his felicitation in the inaugural function of this conference. Sir, your speech on Vedic mantras, hymns, and ancient discoveries was wonderful hearing from you. Thank you, sir. Sharing different ideas together in a common domain leads a conference. I extend my heartfelt thanks to our keynote speaker of today's conference, Ismail Nasik Gangul, Faculty of Arts and Science, Uldag University, Turkey. Gangul sir, Teşekkür ederim. Sir, you have been in association with us for 3 years. We are very much grateful for having you with us. So we are very happy, and we'll always be happy if you are associated with us. And we always wish to have you in person too. Thank you so much for being with us today, sir.
Thank you.
Once again, Teşekkür ederim. I express my heartfelt thanks to Head PG and Research Department of Mathematics, Convener ICCSPAM 2021, Dr. V. Gotlavani Madam, for her constant support and encouragement. Thank you so much, ma'am. Teamwork is the ability to work together towards a common vision. I express my heartfelt thanks to the coordinator of this conference, Dr. M. Venkatachalam, and all organizing secretaries of ICCSPAM 2021 for their support to make this inaugural function a grand success. I express my sincere thanks to all faculty members of our department, research scholars, students, and participants from our institution and other institutions in and around India and abroad for gracing this inaugural function of ICCSPAM 2021. My special thanks to our teachers, our mentor, Dr. R. Devi Madam, former principal of a college, Dr. K. Muthukumarasamy sir, former head of our department, for being with us and gracing this occasion. Thank you, ma'am, and thank you, sir. Once again, I express my heartfelt thanks to one and all for their cooperation in making this inaugural function of 4th International Conference of Current Scenario in Pure and Applied Mathematics a grand success. Thank you, one and all.
Thank you, madam. Thank you.
Thank you, ma'am. I request all the participants to take a break for 5 minutes and rejoin the link.
The technical session will begin at 11:20 in the same link, same Google Meet link. Thank you.
I request all the participants to rejoin the same link after 5 minutes for the technical session 1 of the day. Welcome back all. Participants, now it's time for technical session 1 of the day. And now I request Dr. M. Vigneshwaran Sir, Assistant Professor, PG and Research Department of Mathematics, Kongunada Arts and Science College, to welcome and introduce the speaker of this session. Sir, please.
A very good morning to one and all present here. I feel immense pleasure in introducing our honorable speaker, Professor Dr. Dafiq. He has completed postgraduate course in the subject Mathematica Numerical Computation at Manchester Institute of Science and Technology, Manchester, United Kingdom. He has completed PhD in the year 2007 from University of Ballarat, Victoria, Australia. He is currently working as Professor in Mathematics Education, FKIP, University of Jember. He is working as an editor in 7 reputed journals, and he has published more than 100 research papers. I invite Professor Dr. Dafiq to deliver the talk on the topic on the resolving strong domination number of graphs in unison. Sir, please.
Professor, sorry inconvenience. You are in mute. You have to unmute your microphone. Yeah, fine. It's fine now.
Thank you very much, the moderator. My name is Dafiq. I'm from Indonesia. Today, I would like to share my research study entitled The Resolving Strong Domination Number of Graph. It is a combination of 2 concepts, then we have a new notion. Before we start my presentation outline, the first one is I would like to introduce the place where I teach, the introduction, some new initial research, and concluding remarks. This is my University of Jember. Profile number of students, we have 32,000 students, with number of staff or lecturer is 1,400, and number of faculties is 15. And also we have traveled already to Kongunadu College. So roughly we have 14 hours, 20 minutes traveling by flights last year when the 3rd ICCSPAM's there. And we also have organized international conference, namely ICCGAN conference in 2020 last year, 2021 as well. We will organize, so please welcome if some of you will join with us. We have already established the collaboration between Kongunadu College, represented by Venkata, and we already visit also your college. Okay, so that's the overview of the University of Jember profile. Now, we start with talking about the dominating set and metric dimension application. So dominating sets are useful in wide routing problem. As Professor Changgul said, that mathematics study without an application is nothing. So we need to search whatever the lemma or theorem that we already developed, and we need to search further what is the application of that. And also the application of dominating sets are also useful in wireless networks such as wireless sensor network, wireless and hot network, and also wireless mesh network. There is a publication paper written by Maitai et al. In IEEE transaction of mobile computing on August 2007. You can search there. And also the concept of matrix dimension was proposed to model robot navigation, where the place of navigating agent can change among nodes. So this is the other part of our study. So we are not talking this application in this slide presentation, but we are talking about the fundamental science of mathematics, which is introducing a new notion, namely the combination of dominating set and metric dimension. So this is the basic definition of a strong dominating set and metric dimension. But first of all, I would like to remind you to refresh about the strong dominating set definition. A strong dominating set of graph G is a set D, some upper sets of Phi with the property that for all vertices X, element Phi apart from the dominating set, there is a vertex Y, element of Phi intersection with D with degree of A less than or equal dy. The strong domination number denoted by gamma strong dominated graph is defined as the minimum cardinality of strong domination set. So for the illustration, if we found something like this dominator, it is considered to be a dominating set, not strong dominating set. Since the dominator degree, one of them is less than the other or the other vertices apart from dominating sets. Here, so this degree is 1, the other is 2. But when we consider this one as a strong dominating, then if we have a dominator, some thing like that, which are all the vertices as a dominators, the degree are greater than equal of the other degree of vertices. So this is a strong dominator. Now there are a lot of some basic type of dominating set study. And also independent dominating sets. The other is a local dominating set. And also there is another one, strong dominating set and efficient dominating set, perfect dominating set. So I believe the participant already know, because the study of dominating set established since a long time ago. So there are a lot of publication paper and also a lot of book written by some author about the dominating sets. So, okay, we leave this definition because we now want to combine this basic definition of dominating set, namely strong dominating set with the metric dimension. So now we start to go with the metric dimension. What is metric dimension? In metric dimension, we recognize resolving set. What is a resolving set? A vertex U element Vg resolves a pair of X, Y, element of Vg if distance of U to X not equal of distance U to Y. A set of vertices called as a subset of Vg is a resolving set of G if every pair of vertices of G is resolved by some vertex in S. Now we have the metric dimension number of G denoted by dim G is the minimum cardinality of resolving set of G. So if we consider the illustration like the following, it is only consider a resolver, not resolving a strong dominator. Because we already choose one vertex, and then what is 0 here? 0 is the distance of vertex, this vertex to the dominator, to the resolving set. 0, and this is 1 because the distance between this vertex to this one is 1. This is 2. But this is not resolving strong dominator. So which one? The strong, resolving strong dominator, if we have the combination about the metric dimension and strong dominating. So a lot of natural extension of metric dimension study. We have a metric dimension, partition dimension, which is already written by Chartrand, most of them. Local metric dimension, local partition dimension. We established this one with our research group member, Rido Alvarez et al. In 2020. There are another type of natural extension of metric dimension. We have a fractional metric dimension, local fractional metric dimension. We have a strong metric dimension, local multi-set dimension, and we have a combination in map. This is already studied before, but not strong domination. So it is quite similar with this study, combining the metric dimension and dominating. Then they have a new notion, namely resolve domination. But in our study, we have resolving strong domination. So this is the definition. Resolving strong domination is a set RD subset of VG which RD satisfy the definition of strong domination set as well as satisfy the definition of resolving set. The strong domination number of graph G denoted by gamma RST G is the minimum of resolving strong dominating set of G. This study also is working on your notion of the combination of the above concept. So we have this one for the illustration of resolving strong dominator for part of order 5 and also the resolving strong dominator of cycle of order 5. Now, let me continue the some noun set on dominating set and metric dimension. We also have published a paper with our research group member in our university, especially strong resolving dominating number of graph, but for the strong domination combining with the resolving, now we just initiate to study this one. So we have a lot of references actually for the state of the art of this new notion. All right, the potential research on resolving strong dominating set in the future, probably the student of the Coronado Art College can join this study. There are a lot of, at least there are 4 combination of these two notions. Then you can search and study about resolving total dominating set in the future, or resolving independent dominating sets, and also resolving efficient dominating set, and also resolving perfect dominating set. My student for PhD student and master degree, they already initiate the study these four of the new notion, the combination of resolving in the dominating set. Okay, let me focus for the resolving strong domination set. How is the research design or the step how to prove and to study the existence and also the exact value of resolving strong domination number? So we start with this one. So we start to consider the strong domination set. First, find the exact value of strong domination number. And the second one, the resolving set on metric dimension. You find the exact value of metric dimension number. And by the existing lemma, we try to combine the strong domination number and resolving domination number or metric dimension, and to find out the lower bound of resolving strong domination number deductively by using the obtained lemma. And then the other one, if we couldn't find the upper bound, normally by using a pattern recognition respective to the resolving and dominating set, we try to generalize, and then we try to find out the piecewise functions of the resolving strong domination set to consider it is also happen for the other bigger number of order of the graph. If yes, and then we can consider the proof by using a deductive proof. We also show the distant representation. All distant representation of each vertex in G to the resolving set must be all different. This is the properties. So not only we can have the dominator, we also show the distant representation of each vertex in G to all element of RD, which is. And finally, we finalizing the resolving strong domination number, and to make sure that all steps satisfied of resolving strong dominating set. So normally we give a procedural proof, whether it is inductive, deductive, as well as qualitative approach to prove the resolving strong domination number, which is the optimal one. And finally, we have the concluding. We have proof of the lemma. Now, we like this kind of study about the resolving strong domination number. We and our collaborator, Ika Hesti Agustin, also Ika Wardani and Elsa, and also Fenkat. This paper already done. We already have 5 theorems. We introduced a new lemma to establish the lower bound of the resolving strong domination number. It is written in the lemma 1, let G be a connected graph given that gamma asti is a strong domination number of G, and dim G mean the resolving number. Yeah, in other words, we say dimension of G. This metric dimension is resolving number of G. The resolving strong domination number of gamma of G satisfy maximum strong dominator number and dimension number less than equal. So the strong domination number in between maximum the left side and minimum of the other side. So there is a strong correlation between strong domination number and dimension number to consider the lower bound of strong domination number. So we have this kind of proof. First, we establish the left side of the proof. And finally, we have maximum gamma strong domination number and dimension number less than equal strong, resolving strong domination. And the other continue with the right side. Then finally, we prove the strong domination, the resolving strong domination lower bound. By having this kind of lemma, which is the lower bound of resolving strong domination number, then we establish a new theorem. The new theorem we initiate. This is the initial result on resolving strong domination set. We try to put the simplest graph first to characterize whether in the future we can have characterization of any graph or graph which is having a specific property. For example, regular graph or unicyclic graph or whatever. So, but for the initiation of the new study, normally we begin with the new graph with the very simplest one first. So this is part. We have a graph RST. It is resolving strong domination number of part, either 2 if n equal 3, and the floor, the ceiling of n over 3 otherwise. We have also the other theorem for the cycle. Let's see n be a cycle graph for every positive integer n greater than equal 3. The resolving strong domination number of Cn also equal. Yeah, it is the same with the happen with part. And this is the illustration of the resolving strong dominating sets of theorem 1 and 2. This is for the part of order 10, and this one is resolving strong domination set of cycle of order 12. So look at here, this vertex with the square around is so the dominator as well as the resolver. So what is the dominator? Because all vertices apart from the dominating set are dominated by this dominating set. Not only that one, after we establish the dominator, and then we should show the distant presentation of all vertices must be different. So if we have 4 dominators, strong dominator, of course, the distant representation, we have 4 elements. Why we consider 1? Because V1 to V2 is 1, the length. Yeah, the path length is 1. V1 to this one is 4. 1, 2, 3, 4. So we have 1, 4, 7, 8. So all those distant representation of the metric dimensions are different. So this satisfies the property of resolving strong domination sets. So we have theorem 3. Let Kn be a complete graph for every positive integer of n greater than equal 3. The resolving strong domination number of Kn is n minus 1. And theorem 4, we have a friendship for every positive integer of n greater than equal 2. The resolving strong domination of friendship equal n plus 1. And we have the illustration of a strong dominating, resolving strong dominating sort of theorem 3, 4. So this one, the graph representation for the illustration, and for the friendship, we already have this one as well. And can anyone have or the less number of the element of the resolving strong domination set? because we have this kind of the dominator, so it is very hard to make less the element of the resolving strong domination set. So this is the optimal ones. Okay, now we continue theorem 4. Theorem 5. We have a fan. Let Fn be a fan graph for any positive integer. So we have two cases here. For n element 2, not element of 2, 3, 6, yeah, the order, we have established the exact value of gamma of solving strong domination number, which is a floor of 2n plus 2 over 5 plus 1. But for 2, 3, 6, the order of the fan graph, we haven't found it. Yeah, even it is very small order, but it is very hard to find out. Yeah. Theorem 6, for will, also we have graph. For every positive integer, again, it is hard to find out will of order 3 and 6. Yeah, the list of the resolving strong domination number. But for the other one, we have this our exact value of the strong resolving strong domination set. Participant, maybe you are wondering how to prove it. It is important as well. Apart from showing the theorem that we have already found in this paper, I also give one lemma, how to prove the lemma in a resolving strong domination set study. Okay, let me show you. Yeah, so this is the illustration for the theorem 5 and 6. So the proofing first, the proofing, I have already mentioned in the research design, proofing starting from the establishing the lower bound first. Of course, we already have a lemma 1 as the lower bound for general G. When you find out the exact value of the specific graph, of course, it is easily, and it is very standard to prove, establish the lower bound. And also, after that, find out and obtain the upper bound. If the lower bounds equal with the lower bound, the upper bound, yeah, if the lower bound equal certain number, and then we can consider the exact value. So this is for Cn, yeah. So first of all, we need to find out the cardinality of vertex sets and also each set, yeah. So I remind you, the first one, how to prove it, establish the lower bound first. The vertex set of cycle, of course, already participant already know the number of vertices and also the number of edges is n. It is the same. According to Mortaza et al., 12 that I have mentioned in the previous reference, and also Rautenbach at number 3, the reference, we have dimension number of Cn is equal to, and the strong domination number of Cn is equal n over 3, a floor, yeah, n over 3. Based on the lemma 1, we already this kind of lower bound. Thus, the lower bound is between floor n over 3 and floor n over 3 plus 2. This is the lower bound and also upper bound of the resolving strong domination number of Cn. So of course we have a gap because the difference is 2. So how do we find the exact value? If we can show the gap, if we still have a gap, so the work is not completed yet because it will leave an open problem. So we need to fix the exact value. So the exact value, of course, we try to go further with try to do a counting argument about the cycle of order n to find out the resolving set as well as the dimension set as well as the strong dominating set. And finally, at the end, we need to obtain the resolving strong domination number. So here we have two cases. Case one, we try to characterize for n equal 3 of Cn. Of course, we only have V1, V2, V3 as the vertices. And of edges, we have V1, this one. There is one strong dominating set, but unfortunately, it is not the least resolving set of Cn. Thus, the lower bound for n equal 3 of resolving number n greater than equal to. By choosing two vertices out of 3, it will give the list of the resolving number. Those are also less than equal to. By those cases, two cases, it could conclude the gamma RST, which is resolving strong domination number of C3 is equal to. Now, we try to 4 n equal 3. So this is resolving domination number search. So this is the second step. Okay, regarding to Rothenbach, in the number 3 of our reference, we have the dominator is a floor n over 3. And the superset of the dominating set is as well as the resolving set. So we can say that the resolving strong domination number of Cn is equal floor n over 3. So that's enough for this one. But it is already finished? No. We need to have another step for the proving of this one. We need to show the resolving strong dominating sets. We do not only show the resolving strong domination number, we need to show the resolving strong domination set. And finally, we have this kind of piecewise function, for the resolving strong domination. In order to know in which vertices the strong dominator are. So this is important, So in our case, for the cycle, the resolving strong dominating set is shown in this piecewise function. And we can see that the cardinality of RDCN is n over ceiling and over 3. So this is the resolving domination set. This has been complete? Not yet. We still have one step to show the complete proof of a strong, resolving strong domination study. What is that? The distant representation. So we need to have this one. Furthermore, the distant representation of every vertex of Cn to all vertices in RDCN must be all different. So we need to make the table. You can have another way to prove apart from having a table. It is okay, but we need to guarantee that all the distant representation must be different. So we can see in the table the distant representation of every vertex of Cn to all vertices n above are all different. And finally, it concludes that the resolving strong domination number of Cn is ceiling of n over 3. That's conclude them. So for the other rest, I believe it is easy to see in our paper, which will be submitted in the ICCSPAM 2021. Yeah. Okay. Now let me conclude our study on resolving strong domination study. The conclusion: is this study complex? Yes, it is considered to be NP-hard problem. We initiate to study this new notion, the combination of two concepts of strong domination thing and metric dimension. The strong domination is also NP-hard. Metric dimension is also NP-hard study. And we'll give a complex problem. Even more for any graph, it is also NP-hard problem. The second one, can we determine the lower bound? Yes, we already have the lower bound. And maybe in the future, upper bound actually we already established. But maybe we need to have a more sharper upper bound in such that the lower bound and upper bound is getting very close, so gap is not so big. If it is getting very close, then we can perform the other study easily. And the other one, can we obtain the resolving set strong domination number of any graph? Yeah, for special graph, we already initiate the initial result. Yeah, for example, here we have a path, cycle, complete, friendship, fan. But otherwise, we need to do more study. Other type of graph, for example, the graph which have a specific property. For example, regular graph. For example, also unicyclic graph, line graph, Kautz graph, the Boolean graph, voltage graph, and everything. So that's why in the last my presentation, I will give you the open problem of resolving strong domination study. Probably a student and participant in this meeting will work on this kind of study. The first one, that determine the exact value of resolve from domination number of any family of graph apart from graph in this paper. It is very nice for master degree thesis, but I believe for the PhD thesis is not enough. The PhD thesis at least start with the determining the exact value of resolving strong domination number of any operation of graph. For example, coordination of graph and power graph or other Cartesian product of graph and other type of operation of graph. And it is not enough sometimes for having a good publication in good reputable journal. Of course, we need to lower the upper bound. And lowering the upper bound is very important. That I said that because we can make the gap is getting smaller. So if the gap is getting smaller, then finding other characterization of any graph, it will be very easier. So this is important to find lowering the upper bound of the resolving strong domination number. So finally, we can find the sharper upper bound. And it is very important. And the last one is a very high level of study. If we can do this one, we have a good publication in good reputable journal. Yeah, namely characterizing the resolving strong domination set of any graph, which the graph element have specific properties. For example, regular graph, unicyclic graph, line graph, voltage graph, etc. I believe this one is the end of my slide presentation. I'm very welcome if there is a question and discussion in this session. Again, I would like to thank FanCard and other event organizer of ICCSPAM 2021. It is very nice conference, and hopefully in the future we can improve our number of publication as well as the quality of publication on combinatorics. Thank you very much, and I'll give it back to the moderator.
Participants, is there any queries? If so, please. Participants, is there any queries? If so, please proceed.
Yeah, so please, if there is any question, I'm very pleased to have a discussion in this session.
I repeat, participants, is there any queries? If so, please proceed.
Yeah.
Sir, there is a query.
Moderator, can you read in the chat room? There are a lot of question written there.
Yes, sir, there is a one query. What is the difference between strong dominating set and efficient dominating set?
Yes, yes, okay. I already mentioned in the slide presentation. Let me share the slide presentation again, yeah, in order to make what easy to understand. Yeah. Okay. Okay. This one, the different. Yeah. Yeah. Okay. I have this one. Yeah. Okay. Efficient dominating set. It is in the dominating set study. Each vertex, apart from dominating set, is dominated exactly one vertex as a dominator. And all vertices in dominating set should be independent. So it is the dominating set are not allowed to be adjacent. Yeah. What is a perfect dominating set? Perfect dominating set, each vertex apart from dominating set is dominated exactly one vertex as dominator, but not necessarily they are independent, they are adjacent. My question answer your question. My answer said this question. Moderator.
Mr. Satish Kumar, hope your query is clarified. Participants, is there any more queries? Shall we close the query section? Thank you, sir, for your excellent coverage of the topic and providing encouragement to learn more.
Okay. So my time is enough.
Yes, Professor. Thank you so much. It was an immense pleasure listening to you.
Okay.
Hope next conference, I hope we can virtually, we can physically meet as like the last year. So it's an immense pleasure. Our team, I thank you wholeheartedly.
Thank you, Sweeta. Thank you. Thank you. Thank you very much.
Dear participants, the session 2 speaker is finding some technical issues. So probably his session timing will be rescheduled. So I request all the participants to disperse for the break, and the third technical session will start by 2 p.m. I repeat, the technical session 2 speaker is finding some technical issue. So maybe this session will be postponed and time will be intimated later. So now we are breaking for our lunch. So the next session, technical session 3, will start by 2 p.m. So all the participants are requested to join back to the same Google Meet link by 1:50 p.m. I repeat, all the participants are requested to join back by 1:50 p.m. The attendance link for this session is found in the chat box. All the participants are asked to fill the attendance link. Thank you so much.
I request all the participants to fill the attendance link in the chat box. We expect all the participants to rejoin the link by 1:50 p.m.
Dear participants, technical 2 session will start now. The technical issue for the speaker is resolved now. Please stay in the link. Dear participants, don't leave from the session. Please stay in the session. The technical session 2 will start now.
Okay, morning.
All the participants are requested to stay in the link. The technical session 2 is about to start. Sorry for the inconvenience. I request all the participants to stay. The technical session 2 of the day is going to start.
Let's begin the technical session 2 shortly within 5 minutes. I request all the participants and speaker to patiently wait. Now it's time for the technical session 2 of the day. Now I call upon Dr. M. Venkatachalam Sir, Assistant Professor, PG and Research Department of Mathematics, Kongnadu Arts and Science College, to welcome and introduce the speaker of this session. Sir, please.
Thank you, Niveda. It is my great honor to introduce about
Hello.
Thank you, Niveda. It is my very great honor to introduce about Professor Ayman Reddy Badavi. He is a very eminent professor in the world in the area of algebra. He has published many papers. It is with deep pride and humility that I introduce the keynote speaker for the technical session 2. He is currently working as professor in American University of Sharjah and worked as visiting assistant professor in Emory and Henry College. He is a permanent member of American Mathematical Society since 1994 and a permanent external member of the FPC, College of Business. He has received awards like Babylon's Peer Reviewer Award for the year 2018 and 2019, Excellence in Research Award for the academic year 2014 and 2015, Excellence in Teaching for the CAS Teaching Award for the year 2012 and 13. He has published 5 books around. He has published many research papers and 17 book chapters. He has done 7 funded projects in various funding agencies. He has worked as editor and reviewer for and referee for several Scopus indexed journals. And he is the editor-in-chief of the Palestina Journal of Mathematics. It is currently indexed in Scopus. An investment in knowledge always pays best interest. I invite Professor Dr. Ayman Reddy Badavi to deliver the speech on one observing weekly primary ideals of competitive rings. Thank you, Professor. Now I hand over the session to the Professor Ayman Badavi. Thank you.
Professor, it's not audible. So your mic is in mute. Please unmute.
Can you hear me now?
Yes, Professor.
Okay.
Yes, you can proceed. Thank you.
Okay. First thing, I thank you for the introduction and for the invitation. That's very kind of you. So I will start my presentation. Let's see this one. Okay. And can you see it? Can you see my file?
Sir, your screen is yet to be seen, sir.
Is what?
Yeah, it is about to be presented. Just a minute, sir.
Can you see it? Is it clear? Yeah.
Professor, still we cannot see your screen. Can you please stop presenting and reshare again so that we can know whether it has been seen?
Okay. Okay, let me try again. A window.
Actually, you can just click the present now, and you can just click your entire screen so that your entire screen can be seen. Or if you have the presentation in your minimization, you can just use a window.
How is that?
Yeah, I'm just finding, sir. Yeah, now it's fine, sir. Now it's fine. You can proceed, Professor.
You see it clearly? Okay.
Yes, Professor, it's fine. You can continue.
Okay, thank you. Okay, this talk will be on which is better, this way maybe? Oh, sorry. I think, yeah. Yeah. Okay. All right. So this is a talk about one absorbing primary ideal. And so what is this all about? One absorbing primary ideal of commutative rings. Okay, let me start by saying that this talk rely on two papers with my co-author Age Yetkin. She is a Turkish mathematician. We end up writing these two papers recent. One of them, I think it's already appeared 2020, and the second one get accepted. If you are, of course, in this talk here, I will just summarize or, tell you what is this about. If you are interested in these two papers, they are available free download from my personal webpage. And you see it down here, my personal webpage. Okay? All right. If there is a problem, please stop me. Is it very clear or not yet? Or I make it bigger?
Professor, the screen is fine. The voice is breaking a bit. Professor?
How is that? Is that better?
Yes, Professor, it's fine. You can proceed, Professor.
Is it good now?
Yeah, now it's fine, sir. Now both you're audible as well as the screen is also clear now. You can continue, sir.
Okay. So we'll do that. Okay. So I continue. I continue with some history. Throughout this talk, rings will be always commutative. And I start by reminding you with some definition that I need for this talk. One of the definition, what we mean with a quasi-local ring. If you have a commutative ring and the ring has only one maximal ideal, then we call it quasi-local ring. If you read from other books, Some books, they call it only local ring, but here I will call it quasi-local ring, okay? And you need that in order to continue with my talk. You need this concept. You need to know what I mean with the quasi-local. It means commutative ring with exactly one maximal ideal. And if you have a proper ideal, what I mean with the radical of I. Radical of I, as all of you know, but I remind you, are the elements in R in the ring where R to the n is in I for some positive integer n bigger or equal to 1. So that means I, as an ideal, live inside the radical of I, because you can always let n to be 1, right? And definitely all the elements I are in the radical of I. So using street language, what I mean with the radical of I, I mean exactly what I told you. I mean all the elements in the ring where R to the n is in I for some integer n. Okay, in 2007, Badawi, and that's me, we generalized the concept of a prime ideal to something called two absorbing ideal. Okay, what do we mean with the prime ideal? As all of you know, prime ideal means whenever you have a product of two elements in the ring, if you have two elements A and B in R, and A B in I, then A in I or B in I. Okay, so the concept of a prime ideal rely on a product of two elements in the ideal I. Two absorbing mean rely on the product of three elements in I. So if you have an ideal I, we call it two absorbing ideal. If whenever you have three things in R and A, B, C in I, then A, B in I, or AC in I, or BC in I. Okay? That's exactly the definition of two absorbing ideal. So if you look at the definition of two absorbing ideal, what we call it the prime ideal, you can call it now one absorbing. Why one absorbing? Because remember the definition of prime has to do a product of two things in I, and you need one of them to be in I. Here, two absorbing, meaning I have three things, product of three things in I, and I'm asking that a product of two to stay in I. Okay? Still with history, in 2013, we introduced weakly two absorbing. What is the definition of weakly two absorbing? We only added one extra condition. Remember, for two absorbing, we ask whenever you have a product of three things in I, then I want a product of two of these three to stay in I. Here we add, I want the product in I, and I add one more condition that ABC is not 0. Then a product of two things stay in I. So the definition between the difference between weakly and without weakly is this thing here, ABC not equal 0. I add this condition if I talk about weakly. Okay, and as you expect, my colleague David Anderson and I, in 2011, we generalized to absorbing for N absorbing in general, for any N. And what does that mean? Remember the definition of two absorbing. Whenever you have a product of three things in I, then a product of two should stay in I. So in absorbing mean like whenever you have a product of N plus one element in I, then you want a product of N of these elements to stay in I, as it's mentioned here. Okay? So we have so far, we need to know what we mean with two absorbing and weakly two absorbing. And this concept here, I will not use it in this talk for any N. Anyway. Okay, and then in 2014, myself and Ticker and Yetkin, my co-author, the one I told you earlier, we introduced two absorbing primary. What do I mean with two absorbing primary? It means whenever you have three things in I, A, B, C in I, then I want AB in I, or AC in the radical of I, or BC in the radical of I. Okay? Whenever I have a product of three things in I, then I want this condition or this condition or this condition. Okay? Again, what do I mean with weakly? Weakly, I just add one more condition. As I told you, I still need ABC in I, but I ask for ABC not to be 0. When I add the ABC not equal 0, then we mean with weakly. Okay? So we have, and remember again, what is the radical of I? Radical of I are all the elements in R where, let's call it R, where R to the N is in I for some N. So to follow my talk, you need to know what I mean with two absorbing maybe, radical, and you need to know what I mean with the quasi-local. Again, quasi-local means a commutative ring with exactly one maximal ideal. Okay, so now we go to the talk for today. What do I mean with one absorbing primary? One absorbing primary, it means this. If you have a proper ideal, we call it one absorbing primary if whenever, and please look, pay attention to that, not any ABC. If whenever non-unit element ABC, what do I mean non-unit? I think all of you know non-unit mean not invertible under multiplication. Okay? Whenever you select three non-unit element in R and ABC in I, then I want AB in I or C in the radical of I. Okay? That's the definition of one absorbing primary. So one absorbing primary, read it carefully, not whenever you have a product of three things in I, then A, B in I or C. No, the three things you need to select, they have to be non-unit, meaning non-invertible elements that are not invertible. And if the product of these three things in I, then I want AB in I or C in the radical of I. Okay, and let me remind you what I mean with a primary ideal. Primary ideal mean whenever I have A, B in R and A, B in I, then A in I or B in the radical of I. And here A, B can be anything. Whenever you have a product of two things in I, then A in I or B in the radical of I. That's the definition of a primary, where the definition of one absorbing primary, the three things we're going to select, they have to be non-unit. And when I multiply them and I get an I, then I need A, B in I or C in the radical. Okay, here is something you could observe, that primary always give you one absorbing primary, and one absorbing will always give you two absorbing primary. So these primary, one absorbing and one absorbing, the new term, one absorbing primary, will mean two absorbing primary. Okay, and you're gonna see maybe in this talk that you cannot go in reverse. Okay, all right. I'm sorry, I keep is everything okay? Can you hear me?
Yes, Professor, it's going fine.
Okay, thank you. All right. So let me start by giving you some properties of primary one absorbing primary. Okay, the first one I just told you, whenever you have a primary ideal, then definitely we're going to have one absorbing primary. So you're going to tell me, what about the converse? Can you give me an example of one primary that is not primary? Here is the example. You take the ring A to be the polynomial ring with two variables and K to be a field. And you take this ideal generated by XY, and you do the localizing. You localize A at M. All of you familiar with this from abstract algebra. Then definitely my R will be quasi-local when I localize at this maximal ideal. Okay? Then this ideal, you need to check that, or maybe you will rely on a theorem that I will mention later on. If you take the ideal generated by x squared and xy, this ideal will be absorbing ideal of R. Remember that R is A localized at M. Okay? Yeah? Anything wrong?
No, Professor, no, you can carry on.
Okay, thank you. Then the radical of I will be XR. However, this ideal, x squared comma xy, R is not a primary ideal. So we do have an example of one primary, one absorbing primary that is not primary. What about the second? Because remember I told you, if I is one absorbing, then I is two absorbing. Remember what I mean with two absorbing primary. Two absorbing primary mean whenever you have ABC in I, then you want AB in I or AC in the radical of I or BC in the radical of I. one absorbing always mean two absorbing primary. So can you give me an example of two absorbing that is not one absorbing? And the answer to the question is yes. And you see number 4. Number 4 is an example of, how can I get rid of this? Go. Okay. This bar here, I don't know. I'm trying to get rid of it. Yeah, here we go. If you take your rank to be the integers and you consider the ideal 12R. I mean, you remember R is the set of all integer. Then I will be two absorbing primary. However, it is not one absorbing primary. You can check that the ideal generated by 12 and my rank is the integers. Then this ideal will be two absorbing primary, but it will not be one absorbing primary. Okay. So what are the properties of one absorbing primary? That's the question we need. Well, the first absorbing primary will be prime ideal. In fact, for me, this is the most beautiful result that I never thought it will be correct. Let's read it. The first result, theorem. If you have R and R has one absorbing primary that is not primary, then R must be quasi-local ring. Wow. If you think about it, just chill out and relax and read that carefully. This is kind of, for me, I mean, everything is personal. This is a very amazing result for me. That if you have a ring and the ring has one absorbing primary that is not primary, then the ring has to be quasi-local. And remember what quasi-local mean? It means a ring with exactly one maximal ideal. Okay? Well, so let's stop for a minute. That means if you have a ring that is not quasi-local, then there is no difference between one absorbing primary and primary. The two definitions are equivalent. Okay, that's what you conclude from this result. If your ring is not quasi-local, then the two definitions are equivalent. What are the two definitions? One absorbing primary or a primary. There is no difference between these two. One of them imply the other, and the other imply the first. Okay? And this is, I think, what I wrote here. So if your ring is a product of two rings, then definitely your ring R will not be quasi-local. Then an ideal in R will be one absorbing if and only if I is a primary ideal. Okay. And of course, you come up with this result. Like if you have a product of two, then can you please tell me how the one absorbing primary look like? Well, I just told you that in this case, the one absorbing primary, they are nothing but primary. So that's exactly what this result tell you. Okay, the next thing I'm gonna tell you, you're gonna ask me a question. How do you construct one absorbing primary that are not primary? That should be a good question. We need to know how to construct one absorbing primary that are not primary. Okay? And of course, from previous result, from the previous here, in order to do that, my ring should be quasi-local. Because if my ring is not quasi-local, then one absorbing primary will be nothing but primary. Okay, so I remind you with some definition here. What I mean with a non-zero element, we call it irreducible. If whenever you write X as a product of two things, then one of them has to be a unit. Unit mean invertible element. And also we recall what we mean with the prime, that if X is a factor of a product of two, then X has to be a factor of the first, or X has to be a factor of the second. Okay? Okay, in a quasi-local ring, this I mention here lemma. Why? Because I need it in the proof of what I'm gonna tell you next. And this is kind of also nice that if your ring quasi-local, meaning if your ring has only one maximal ideal, then every prime element is irreducible. So there will be a prime element, meaning if X is a factor of X1, X2, then X has to be a factor of X1, or X is a factor of X2. Where irreducible, whenever you write X as a product of two things, then one of them has to be a unit. And remember, by definition, prime and irreducible, we already assume that X is non-unit. So if your element is invertible, then we do not use irreducible or prime. To talk about irreducible and prime, we assume that my element is not invertible. Okay, here is how you start with a quasi-local ring, and there are many of them, with maximal ideal M. And you select X to be in M. M is the maximal ideal of R. Okay? And M, assume M, the maximal ideal, is not equal to XR. I mean, M is not the principal ideal ring. Ideal is not a principal ideal. M is not generated by one element. And X, I selected X to be in M. Then XM is one absorbing that is not the primary ideal. Okay? So this is how you construct, and to come up with the quasi-local, just choose your favorite integral domain, and then choose a prime ideal and localize R at the prime ideal. Then definitely this will be quasi-local, and then follow the steps. And that's exactly what I did here. in the example I just gave you earlier, that's what exactly I did. I selected my A to be the polynomial ring, where K is a field and M is the ideal generated by XY, and you take R to be A localized at M, then R will be quasi-local. Then I took this ideal. If you notice, the maximal ideal is this one, M index M. And I took this maximal ideal and I multiply it with X. You see what the theorem tell me? Choose an X in the maximal ideal, and then XM is one up. So this one here is one up. So this is how, in fact, you construct one absorbing a primary that are not the primary. Okay? All right. And here are more properties of one absorbing. Okay, what does this tell me? If you have an irreducible element in R, suppose I is one absorbing that is not primary. Okay, so that means I know where I live. That means my ring has to be quasi-local. What can I conclude about the ring? There must exist an irreducible element and a non-unit Y where xy in I, but neither x in I nor y in the radical of I. Furthermore, if AB in I for some non-unit elements AB such that neither A in I nor B in the radical, then A must be an irreducible element of R. Okay, so I mean, in the street language, what this theorem tell me? Tell me if I have a quasi-local ring. Why quasi-local ring? Because I have one absorbing, I is one absorbing that is not one absorbing primary that is not primary. So definitely that tell me my ring is a quasi-local. Okay, if this is the case, then I get some information about this ring. It must contain an irreducible element. We call it X. Remember what irreducible mean? That if X, you write X as a product of two things, then one of these two things has to be invertible element or unit. And another element Y where xy in I, but neither x in I nor y in the radical. And another thing I know, if AB in I, AB are not unit, not unit, non-unit, and neither A in I nor B in the radical of I, then A has to be irreducible. Okay, here is another way to construct one absorbing, but here you have to be careful. This construction will always give you one absorbing, but I cannot guarantee that it is not a primary. So in the next theorem here, let R be quasi-local ring with maximal ideal M and P be a prime ideal where B lives inside. Then PM is one absorbing primary. Okay? PM is always one absorbing primary. Okay. Okay, so the question is then, here is the question you're going to ask me. If you have a ring, a quasi-local, yeah? Is it okay?
Sir, it's okay, sir. You can proceed.
Okay, thank you. Here is the question you might ask me. You might tell me like in a quasi-local, is it like one absorbing primary are different from a primary? Well, not always. Okay, because remember that if we have one absorbing primary, then it has to be that is not a primary, then the ring has to be quasi-local. So the question you're going to ask me, what about if I have a quasi-local? Does one absorbing primary mean primary? No. Why? Here's some examples. First thing, I need to remind you what I mean with divided prime ideal. Divided prime ideal, like if you have P is a prime ideal. So what do I mean with P to be divided? It means if I choose an element outside P, then this element has to be a factor of every element in P. Okay? This is exactly the definition of divided prime. So P, first thing you start with the prime ideal, we call it P. Whenever I choose an element outside P, then this element has to be a factor of every element in P. Okay. So look, and it's known that if this is true for every prime ideal, then R, we call it divided ring. So divided ring mean every prime ideal divided. Okay? And it is known that this class of rings are quasi-local, meaning they have only, each divided ring has exactly one maximal ideal. Okay, so here is a big class of let R be a divided ring. Then the two concepts are equivalent. Then I one absorbing primary if and only if I is a primary. Okay? So the answer to the question is wrong. No. What was the question? If you have a quasi-local, is it always one absorbing need not be one absorbing primary need not to be primary? No. And why? Here is a big clause. Here's the theorem. If you have a divided ring, then the ring will be quasi-local, but the two concepts are the same. Okay. Here is something as working on divided ring, a result observed. Let R be a divided ring with maximal ideal M. If M is not a principal prime ideal, well, we know every maximal is a prime. So here, if I know that the maximal ideal is not a principal ideal, what do I mean a principal? A principal mean the ideal will be generated by one element, like M equal XR for some non-unit X. This is a principal ideal. So here I said M is not a principal. That means M is not equal to XR for every non-unit X of R. then look, what's the conclusion? Then every non-zero prime ideal of R also is not the principal. Wow. Okay, so if you have a divided ring, if the maximal ideal is not the principal, then none of the prime ideals will be principal. Okay? And here is another result related. Like if you have divided integral domain, of course, all of you know what I mean with the integral domain. It means a commutative ring, but the only zero divisor of the rings is zero. So an integral domain is a commutative ring without zero element, except zero. And remember what zero element mean. Like when A is a zero divisor of R, if A times B equals zero for some B, for some non-zero B of the ring R. Anyway, so if you have a divided integral domain and P is a prime ideal, then B to the N is a primary. But I already proved in divided rings, there is no difference between one absorbing primary and primary. So B to the N will be always one absorbing primary. And the same thing. Okay, let me get to Dedekind domain or Bruffer domain. These are classes I do with a Bruffer domain, meaning every finitely generated ideal is invertible. I think I mentioned the definition. Yeah. If you have an integral domain with a quotient field K, okay, and then a proper ideal I, we call it invertible ideal. If I times the inverse of I give you R. What do you mean with the inverse of an ideal? All the elements in the quotient field where Ri is a subset of R. Okay? R in K such that Ri in R. Ri in R. R, we call it a Bruffer domain if every non-zero finitely generated of R is invertible. That means I times the inverse of I will give you R. But this Bruffer domain for finitely generated ideal. Okay, since I mentioned Bruffer, maybe I should tell you what I mean with Dedekind domain. Dedekind domain, we remove finitely generated. So it become if every non-zero ideal of R is invertible. This is what we call Dedekind domain. Dedekind domain, we want every non-zero ideal to be invertible. Where a Bruffer, we want every non-zero finitely generated. Okay, here is a characterization. If you have a Bruffer domain, then these are equivalent. One absorbing always mean primary. Okay, so in a Bruffer domain also, there is no difference between the two things. This is theorem. The first one is kind of interesting. Why? You have a characterization of Dedekind domain in terms of one absorbing primary. Let R be Noetherian. What do I mean Noetherian? every ideal is finitely generated. That's Noetherian. Then the following are equivalent. R is Dedekind domain. This condition is equivalent to 2. So in this theorem, we characterize Dedekind domain in terms of one absorbing primary ideal. This condition, these two are equivalent. And maybe one of the questions you're going to ask me, wow, can I carry on the definition of one absorbing primary in terms of ideals? What do I mean with that? Remember, the definition of one absorbing primary has to do with the element. Whenever you have a product of three things in I, then you want, and these three things are non-unit, then you want A, B in I or C radical of I. What about if I use the ideal? Like, look, for any proper ideals, I1, I2, I3, whenever you have a product of three ideals in I, then I1, I2 has to be in I, or I3 has to be a subset of the radical of I. So that means we can give the definition of one absorbing primary in terms of ideals, because the definition I gave you, it was in terms of element. But these two are equivalent. 1 and 2 are equivalent. Okay, one absorbing primary means that, and number 2 means that. Okay, I think I have maybe 5 minutes. How much time left for me?
Sir, just 5 more minutes, sir.
Oh, okay. So I finish up. I finish up with weekly. And what do I mean with weekly one absorbing? As you expect, when I add weekly, I still use the same definition as one absorbing primary, the same definition, but I add one more condition. I want AB not equal 0. So an ideal, we call it weakly one absorbing primary if whenever non-unit element ABC in R and AB and this, then AB in I or C in the radical of I. Okay, and this is like related to weakly primary. Weakly primary, you just remember a primary and you add the condition AB not equal 0. Okay, you see, read it. I give you a minute to read weakly primary and weakly one absorbing primary. Weakly one absorbing primary, the same definition as one absorbing primary, only we add the condition that ABC is not 0. Weakly primary is the same definition as primary, but we add the condition AB not equal 0. In fact, these definitions, they're inspired by weakly prime. D.D. Anderson and Smith in 2003, they introduced weakly prime. We know what it means. It means AB in I, then A in I, or B in I. Weakly prime, we add the condition AB not 0. So here I have N missing. If whenever you have AB in R and AB in I, then and AB, then A in I or B in I. That's weakly prime. So all these weakly things, in fact, they were inspired by this paper in 2003. Okay, and we achieved some result on weekly, but I think you can read that on your own if you are interested. You see the difference between, I already gave you in details what I mean with one absorbing primary. So I think, you can finish up on your own when it comes to weekly. Yeah. Okay, I think that's a good time for me to stop. Hello? Hello? I think I finish here. So I stop, maybe.
Participants, if there is any query, please proceed. You can post the query in the chat section.
Okay, I have a question for you. Is this lecture recorded?
Yes, sir, it's recorded, sir.
It is streamed in
Will I-
YouTube also, sir. We have streaming in YouTube also, sir. Now people are watching. Besides the Google Meet, we are streaming live in YouTube also, sir.
I know, but my question, can I get a link for this lecture later
Yeah,
on,
that's
not now?
Sure, sir. Sure. I'll just send you your talk, sir. No issues.
Oh, okay, because I am interested in having my talk.
Yeah, I'll just send you the link, sir.
Thank you very much.
Thank you, sir. It's our pleasure, sir. Thank you.
Yeah, thank you. I hope one day, very soon, I will be in India.
So thank you, sir. Thank you so much.
Thank you.
Soon we would like to have you with us in India.
Yeah, I mean, I am a regular customer. I used to come to India 2, 3, 4 times a year. I hope, soon we will start my trips to India. I hope so.
Thank you, sir. Thank you.
Thank you. Okay. So I can leave?
Thank you, sir. Your thought-provoking talk has set a perfect platform for the participants to intensify their knowledge. Thank you once again, sir. Thank you.
Thank you very much. I can go? Maybe I will come back later on. But I think I can go now. Yeah.
Yes,
Now
Professor.
let's break for lunch, and we request all the participants to rejoin the link by 1:55 p.m. Once again,
Okay.
let's break for the lunch, and we expect all the participants to rejoin the link by 1:55 p.m. sharp. Thank you.